Hey, welcome back. So this is going to be probably the final worked example that I do involving normal distributions. And this one's a little bit interesting because we're actually going to work backwards, right? You'll notice that in the problem, we already know the percentage, right? In all the other problems, that's what we were trying to solve for, was the percentage. We started with a data value. Here, let me draw it out, right? So usually we have some data value, which we then convert to a z-score, which we then convert to a percentage or a percentile. Okay. So in this video, though, we're actually going to be doing things in reverse. We're going to start with the percentage, okay, work backwards to get the z-score, and then use a little bit of algebra to figure out what the data value is. All right. So according to the CDC, the heights of 3-year-old females are approximately normally distributed with a mean of 94.5 centimeters and a standard deviation of 4 centimeters. 75% of 3-year-old girls are taller than what height? All right, so we know the shape, we know the mean, we know the standard deviation, okay? And we know a percentage. Okay. So 75% are taller than some particular height. Okay, we don't know what that height is. We can call it X, right? We can introduce a variable here. All right. So like all normal distribution problems, we're gonna start with a sketch. 1, 2, 3, 4, 5, 6, 7. Okay. So the mean is 94.5, and the standard deviation is 4 centimeters. So this would be, let's write this way, 98.5, 102.5, 106.5. This would be 90.5, 86.5, and then 82.5. Okay. And then these numbers here represent the heights. That's our variable. Measured in centimeters. That's our units. All right. So there's some mystery height, right, somewhere here. And all we know is that at that mystery height, 75% of girls will be taller than it, okay? So I know that right here, 94.5, 50% of girls are taller than that height, okay? If I went down here, 82.5, I know that'd be like 99 point something percent of girls are taller than that height. So the height where we would have 75% to the right, I'm gonna guess is probably somewhere around here, right? I don't know exactly, okay? But I'm just gonna guess that it's probably around here. Okay. Now my guess might be completely off, I don't know. But I know it's definitely on the left side, right? Okay, so then let's shade this. Okay. So we know the percentage that's taller than this mystery height X is 75%. Okay, so that's 0.7500, right? I'm gonna write it as a proportion. Okay, so then could you tell me the percentage of girls whose heights are less than this mystery height? Well, if this is 75% on this side, the total area would be 100%, then this would have to be 25%. Okay. All right. So we have actually two percentages. We have the percentage taller than, and we have the percentage shorter than. All right. So what we're going to do now is we're going to take our percentile, right, which is actually this one, right? Percentile is the percentage to the left, less than, and we're going to convert it back to a z-score. Okay. So how does that work? Well, we're going to use table A in reverse, meaning we're going to look up this percentage and then work our way back to the margins to figure out the z-score. Now, we might not find this exact percentage, so we'll just try to find whatever is closest to 25%. So looking here, 23, 26. Okay, so we have 2514 and 2483. Okay, so which one is closest to 25%? Okay, this one is only off by 14 thousandths. Okay, and then this one is off by what, 17 thousandths. Okay, so this one is actually the closest. Okay, so what row is it in? It's in the row of negative 0.6. And then what column is it in? It's in the column of 0.07. Okay. So negative 0.6 and 0.07. Okay, so now we know that, you know, a percentage of 75%, which is equivalent to a percentile of 25%, corresponds to a z-score of negative 0.67. All right, let me show you another way of figuring out the z-score, okay, using the calculator. Okay, so I'm going to go to the distribution menu, that's second vars, okay, and then there's a command called inverse normal, right? Because we're doing things in reverse. Okay, we're going from a percentile to a z-score now. Okay. So it's going to ask for an area. So let's just use the area to the left, 0.2500. Okay, we're going to use a standard normal distribution. Mean is 0, standard deviation 1. I need to specify that percentage is the area on the left tail, and then hit paste. Okay, and so there's a z-score, negative 0.67, right, which is what we got. Okay, but the advantage here is that we could have just based it off the right tail, right? I don't know if you saw that we could have just taken the given percentage, 75%, and then just specified that that was in the right tail. Okay, and you would get the same z-score, right? Negative 0.67. Okay, so we've taken the given percentages, either the right tail or the left tail, doesn't matter. And then we've worked our way backwards to get the z-score. Okay, and now from the z-score, we have to work backwards to get the data value. Okay, which my guess was it's going to be somewhere around 90.5. But again, that was just a guess. All right, so how do we do this? Well, we're going to use some algebra. Right? Remember, we have this formula. The z-score is the data value minus the mean divided by the standard deviation, right? There's 4 variables in this equation, but 3 of them have known values, right? We know the value of the z-score. We know the value of the mean, and we know the value of the standard deviation, right? So if we can plug in the 3 knowns, then we can solve for the unknown. All right, so let's do that. Negative 0.67 equals x minus 94.5, all divided by 4. All right, so just using algebra, I'm going to multiply both sides by 4. And so that's going to give me negative 2.68 equals x minus 94.5. Right? And then we can add 94.5 to both sides now. Okay. And then we isolate x. Okay, so plus 94.5, and I get 91.83 82. Okay, so I solve for x, and remember x was representing this mystery height, right? This height where 75% of 3-year-old females would be taller than. So let's give this units, right? Centimeters. Okay. All right, so just to wrap things up, I'm gonna write just a short 1-sentence conclusion, and I'll say 75% of 3-year-old girls are taller than 91.82 centimeters.